All right, so good morning. Uh, I'm happy that you all made it here safely through the weather. I definitely had a bit of a difficulty getting here, but we all made it. This is tutorial 7. I am excited to share some control rig basic stuff that I thought is important to mention related to the the B-Bone lecture content that you've been working on with Gavin, as well as what we're going to be doing next week for for the lab activity or lab assignment number 2, which is going to be the arm rig part 2. So we will take what we learned from the past few weeks and expand on them in an arm rig created with lab assignment 1. And so I understand it's a bit annoying to have back to back to back assignments now because that's just the way the schedule is working out to be. But this one should just expand a bit on what that first arm rig was. At the minimum, we're going to be adding some IK to it, some switching, and then possibly a little bit of bendy bone stuff at the end. And yeah, it'll be very fun. And you'll have lots of information that I'll provide in the actual lab assignment itself. And it will be available from Wednesday, March 18th at 8 a.m. until Monday, March 23rd at 11:59 p.m. So you get a good amount of time, about 5 days to complete that. So stay tuned for that. All right. So today's agenda, what will we review today? So today will be a shorter day for sure. Not as much content to cover, or it might be quicker to get through than usual. So want to talk about just review on skeleton layers, and then look into just the animator interface with the bone display, collections, custom shapes, and widgets. IKFK systems with pull targets, drivers to switch between them, and then bendy bones. Pretty much a lot of this is stuff we already know pretty well or decently well. I just want to sort of showcase some more examples and possibly some add-ons that you can use for widgets. I have an add-on that you can use for that. And yeah, let's get into this shorter day. So just to recap, I wanted to talk again about skeleton layers. And this is kind of that sequence of bones that we are learning in this class, in this course, starting with, of course, the deformation bones, which are deforming the mesh. We set this, we leave it. We ideally want to touch these least because they're touching or they are interacting most with our meshes themselves. And that's where this newer bone, the intermediary bones, come in. These are constrained directly to the deformation bones, and they are the in between the deforms and the controls, keep us from touching the deformation bones, right? And so I'd say that the intermediary bones aren't always absolutely necessary. However, it is good practice to do so because it it allows less future problems later, or if you make a mistake, it won't be as destructive to the actual deformed mesh itself. And so those two are pretty much the same. It's just an extra layer in between the deform and intermediary. And then after that is the mechanism bones, which it's you can consider this a control bone, but you can distinguish it with the MCH name. It has the control bones logic, and it's invisible most often because you don't really need to see it. It's just extra clutter on the screen. And these are things such as your FK bones, IK bones, your any sort of bendy bone functionality is usually going to be hidden as kind of an MCH bone. And the control bones, at least the ones that are animator facing, these are the ones that are displayed as widgets instead of just the regular bones to help distinguish between bones you can interact with and bones you can't. And leading into the next part, we're going to talk about our animator interface. This is what animators mostly interact with. So to change, of course, we've been learning to change the bone display. We have these two properties in an armature where we can change our bone's visual display. We have on the left side, we have the armature wide viewport display, which changes the entire armature at once. And so this is where you can turn on your bones in front, your axes, the names of them, etc., etc. And then on the right side, we have the per bone display. This is great if you want to specifically choose colors for a specific kind of bone or a specific type of visual display for the bone instead. And you can make it invisible here, you can make it selectable. And so, yeah, it's good to know that, I mean, it is pretty self-explanatory with the actual human icon indicating the entire humanoid or the entire mesh, or not mesh, the armature, and then the bone meaning the per bone, right? Now, custom shapes, I believe we have touched into this a little bit, but I just want to really hone in on this today. We can change the way our bones look here with custom object shapes. You can see this is in that bone tab on the right here. And if you scroll down, you can see a drop-down menu for custom shape, and then you can add a custom object right in there. And that leads us into the next section we'll cover, because as much as you can take a curved object or a mesh you make and then plug it into here directly, it can be a bit annoying, especially for a lot of objects you want to quickly change their custom widget shape to. And so now we're going to be talking about custom widget shapes, and these are going to be used to greatly improve our control rig's work visual presentation. And so, as mentioned before, widgets can be added into that custom shape slot to improve the visual clarity of the rigs we're making. So you can see here, this is the same ARM FKIK with switching rig that I worked on for this. And you can see these are the exact same bones. However, the second image has some custom widgets I decided to put on it. And some of these I made myself, some of them were part of an add-on, and I'll show you about that in a little bit. But it really does help to differentiate different parts of your rig and what they're for. You can see that for one, the color coding makes a big difference in how you perceive the model. And the shapes I chose, actually before I talk about that, I chose red for my IK and then yellow for my FK. No reason, that just seemed what was calling to me. And at the very bottom there, I had this sort of bluish gray cog or gear wheel, and that's for the actual control switching, the switching property for the IKFK is on that gear down there. And I also chose the shape specifically because I feel like anything that you would move and also be able to rotate, I chose to have a square. It just felt like something that makes sense to, if I see it, I'm like, okay, that's something I can move and rotate. And then anything that is, you can see here, anything that is a circle, it's specifically for rotations. That's just a way to differentiate further your model, and it's all custom to you and what you need for your specific rig and your workflow. And this is where I talk about Bone Widget. So this is a free add-on that you can get on the Blender website, I believe, or just search Bone Widget on Google. Bone Widget add-on. Yeah, Blender extensions. Yeah. How's it going? This is a great add-on. I love it. It helps tremendously to improve the widget creation time. Simply select your bone in pose mode, and then you can select from this drop down here, you can select any of these by default options, or you can create your own and then you can save it as well. And then once you click create, then you can have this custom shape just instantly added to your bone in the way I showed you, where you go to that custom shape option and just click and then select your bone or select your widget. This just automates that process for you. Simply select the bone you want to add and then choose the widget from the library, make it your own. And then any widget you select will reside in a new hidden collection. And then I left the link at the bottom down here for you. And before that, I want to show you an example of me kind of getting it working. So I'm just going to, I'm going to hide this part of my collection here. Yeah. So let's say cursor to origin. I create, oh, do I have the add-on on? I do not have it on this computer. Let me go through the process of getting it right now. So I'm just going to create a bone. Here's my bone. I'll put it in its own collection. Armature in here. So if I go into pose mode, I could absolutely go in and select a custom object, and then that can change the visual display of the bone. Like I could create a curve, a circle, and then select the bone, pose mode. So I'm selecting that bone specifically, and then boom, boom, and there is my custom widget shape, right? And then I can customize here the rotation, translation, and scaling. So the reason you'd want to change the translation here is because you can see the actual bone's location and pivot stay the same. It's just the visual display is what changes, right? And that's what it's so powerful about this. You can really customize it to your liking. However, the process of making your own custom shape it can be a little tedious for sure. So I can go to Blender extensions, get bone widget, get add-on, drag, and drop. And it will install the add-on with the repository at extensionsblender.org. Click OK. So now I can just go in pose mode, and if I scroll down, there's a rigging option now in this end menu over here. And you can see I can click on this icon here and then choose any of these options available. Let me do the rhomboid, and then click create, and then it creates it for you. Now you can see it has those offsets I created already, so I can just undo all of them. So there's the rhomboid, and then you could even edit the widget itself, right? And so whenever you create a new widget, it doesn't overwrite this one. It creates a brand new one. You can see here there's a new collection called widgets armature 02. So it just has all the widgets for this armature. And yeah, it's a great add-on. Highly recommend it. And I'll show you some examples in what I'm going to show in a second. So back to our content. We are going to be discussing just a bit of FKIK, just really honing in on it once again. This is the next step after making the deformations and intermediate skeleton. And instead of me talking about this, at least for the beginning, we're going to watch a really fun video, as much as seems relevant for us, and I'll just let it speak for itself. So I'm just gonna let me just mute up here.
Arms. They've got something of a mind of their own, and they can be one of the most expressive parts of a character. In 2D, it's really easy to animate them. You just draw the arms, but in 3D, it's a lot more finicky, because in 3D, you have to animate each individual part of that arm. You can't just draw it. So it's a lot more difficult to kind of wrap your head around, but you can usually do it in one of two ways. You can start from the shoulder to the upper arm to the lower arm to the wrist, or you can start from the end of the arm at the wrist and then have everything else follow that movement. That's FK versus IK, and each mode kind of has its own purposes. FK is very predictable, it's more precise. You're starting from the top and going down, and you have control over every part of it, and it's rotation based, so curves are a lot easier. You can do big sweeping motions with FK. And meanwhile, IK is all about positioning the end of the chain, so naturally it's better at straight motions. So if you wanted to have your character throw a punch, for example, you would probably do that in IK because you can have the punch go in a straight line. FK is good at animating rotations, while IK is good at animating positions. But that doesn't mean you need to necessarily stick to either one. For example, if you wanted to blend between the two in the middle of a punch, then you can do that. You can wind up the punch in FK and then throw the punch in IK. Or since IK is good at keeping a hand stuck in place, then you can have it stuck on a table. You can have it placed on a table and stay there. Or you can slam a fist on a table and have it be really forceful that way. So first you wind up the arm in FK and then have it come slamming down in IK. And then because it's in IK, it will stay there. So you can animate the rest of the arm, like the shoulder, sort of reacting to the slam of the fist. And all the while the fist is locked down and stuck. Let's say you need to have one of your arms or hands stick to something that's moving. Like if you have two hands on a pull, for example, you can set one arm to IK, and you can even have the other arm in FK and have it move around while the IK arm is stuck to it and rotating with it. You could also have the IK arm stick to the hips or the head. IK is just good at getting something to stick, basically. You can even animate a finger in IK if you need to hold the end of the finger in place with the rest of the hand following it. For example, if you want to have the finger push a big button and have the hand sort of react to that push, then having the end of that finger in IK is a really good idea. That said, you don't need to have IK stick in place. You can have it follow the rest of the arm and the shoulder just like FK does. It's usually a little obvious when beginner animators are animating an IK because they'll tend to have the rest of the body move while the hands are sticking in place. So if you like animating an IK, and that's fine, just have the IK follow the upper body and then everything else feels natural. You can get the ease of use out of animating an IK while making it look a lot more natural to have it follow the upper body. Let's come back to this technical stuff later and talk about characters and how you can animate arms to be expressive and emotive. The easiest way to think about this is to get into a character's head and try to communicate what they're thinking with their arms. We don't just intentionally and consciously move our arms around, but we move them unintentionally too. Like if a character is afraid of something, they're going to raise their shoulders and straighten their arms. This is when your arms are sort of moving by themselves, so to speak. Typically, when animating reactions like this, the shoulder reacts to everything first, and then comes the rest of the arm. Kind of like the farther away the body part is from the brain, the slower it takes to react to whatever's going on. Instead of your arms snapping to a pose all at once, it ends up feeling a lot more natural if you stagger that motion out to the rest of the arm, doing one at a time, kind of cascading forward. That said, if a character is intentionally raising their arms, we might change which one goes first. Like if they're pointing at something, their hand is probably going to lead that movement, and that hand should come first. Or they might raise their elbow first and get their arm into position, rotating their whole arm before pointing with their finger. Starting with the elbow almost builds. All right, let's talk about spaces. Remember how I mentioned that if you wanted your IK arms to feel natural, you can just have them follow the upper body? This is a concept called space switching. If your arms are following something, it's in that something's space. So if it's not stuck in place, but instead moving with the upper body, then it's in the upper body space, or usually in our case, the shoulder space to be specific. If the IK arm is stuck, then it's in world space, i.e. it's not following anything but the world itself, which doesn't move. But IK isn't the only thing that can switch spaces. You can also switch spaces for FK too. So let's say that normally the FK arm is in the shoulder or upper body space. So it's always rotating with the rest of the body, including when the character bends over and turns around. But if it was instead in the world space, it will still move with the upper body, but not rotate with it. So if your FK arm is in world space, then you could, say, raise the shoulder without raising the whole arm. This can make for some really natural shoulder movements without having to lower the arm back down as you move the shoulders up. I personally prefer doing as much animation as possible while the FK arms are in world space because I think it creates the most naturalistic looking animation out of anything. Elbows. We're going to talk about elbows. Space switching is super useful for elbows. If you're leaning your arms on a wall, for example, you're not going to get much of anywhere with just IK. Your IK can stick in place, but your elbows could end up going right through the surface. Space switching can solve that. Normally, the elbows are in the shoulder space and move with the upper body, but if you need them locked down, you can switch them to world space and keep them locked down even when the rest of the body and the arm is moving with it. One of my favorite parts of Richard Williams' Animator's Survival Kit is how he animates this fist slamming down. He leads with the elbow, and then the forearm, and then the fist. And like I mentioned, this is a lot simpler in 2D animation than it is in 3D, but here's a little breakdown for 3D animators. Animate the arm in FK for the raise, lead with the elbow, and then as the elbow comes slamming down, switch that elbow to world space. So as it makes contact, it's going to stick in place. And then finally the forearm comes down and the fist switches to IK. So the result of that is that you have your forearm, your elbow, your fist, all stuck in place while the character can still move around without clipping into the surface. And that means you can get a nice reaction out of the shoulder and the rest of the body in reaction to the fist coming down. So that about covers everything I want to talk about with arms. This is something of a series.
All right, so that's pretty much it for that introduction video. I really like that video. It's really informative and helps a lot with me understanding this right away. And just to recap, four kinematics, rotation-based, proximal to distal, meaning close to far relationship, and it's good for swinging motions. Our body works in a four kinematics fashion. You can see here I pointed the arrows out from the shoulder back out to the hand. And then IK is inverse kinematics, location-based, distal to proximal, meaning far to close relationship. And it's great for precise placement of your extremities. So in this example, I drew from the hand to the elbow to the shoulder. So FK, your body works primarily like this. You just don't realize it most of the time because our bodies are so good at doing IK. If we leave our hand in space, we can kind of move our hand around it with those muscles that we don't fully, we just subconsciously are able to do IK. However, our body is for kinematics based. And you can see here that the reason why we want to use both is because of the FK problem, which is counter rotation. Imagine we had FK and we wanted to animate climbing up a ladder. We'd have to adjust the rotation of the arms every single frame we move upwards. Our bodies naturally sort of allocate for this or substitute for the movement upwards. If we stick our hand onto a ladder, it transfers from our local space. Think of an imaginary local space to a imaginary world space, which is where the ladder is. Because if we run around or if we move, our bodies, our hands follow our bodies, right? Versus if we kind of grab something in the real world, our hands now become attached to world space. And you can see this relationship here. IK allows us to lock a bone in place, and previous bones will rotate around it. FK is a pain. You have to rotate every single bone around that hand to keep it in place. And even still, it does not align in the animations. But we still have FK for those fluid rotation-based movements. And yeah, pull vectors are the object the elbow, knee, etc. will look at while in a bent state. We have to make sure our IK limb has a slight bend towards the intended pull direction to ensure the IK constraint will choose the correct axis to point towards. And in this case, that's the pull vector. So you can see, I will showcase in a second, that bend in the MCH bone. But you can see here it tracks really nicely. And if I go here, into our control rig showcase, I will showcase everything we just discussed within this Blender scene I created. So starting with forward kinematics, this is a very familiar looking scene. This is the rig from the assignment 1. You can see it's a pretty straightforward FK system. You see that first bone is tracking the transformation. The other one doesn't track anything. If anything, I should have locked those other 4 bones from being able to be moved, because we don't want to move them, we just want to rotate them. However, that first bone is something we wanted to move, so it's okay. But you can see if I rotate it, everything down the hierarchy, the bone hierarchy, rotates properly. You can see the corrective shape key on the elbow there, or on the bicep there, and then the wrist also rotates. This is pretty straightforward. Everything is nice and curved, and we can easily get those fluid motions with this setup. And you can see I can disable the control, MCH, and deformation bones. And it's good to color code it for that reason. You can see the difference. And now moving on to the next one, we have our IK setup here. Very similar, pretty much the same bones. However, the visuals were changed a bit for specifically the wrist and the pull vector. And you can see if I start to move the wrist here, the chain will follow suit. And you can see if I go back to the FK rig here, if I show you the constraints for this one, they are copying rotation only. So that's the only constraint on this rig. It is at the deform level and the mechanism bone level. However, the control itself does not have a constraint because it is the one controlling the rig. However, if I go back to the IK rig here, you can see the wrist has a copy rotation because it's copying exactly what it's copying exactly what that IK control bone is doing. And the reason I named it like this is because I'm sort of starting with the most widespread, least specific to the most specific at the right. So L is very general, it's half the rig. Control is all of the control parts of the rig. IK is the schematics section of the control rig. And then wrist is specifically mentioned what part of the body this bone is. So it's just a way from most specific to least specific to most specific. And so that orange or yellow box is what that wrist is constraining to. So it's isolated movement. We don't have to worry about the chain messing up this rotation on this wrist. And so if we rotate the pull vector as well, then we can see that the chain sort of follows suit. And you can see the IK constraint is on the forearm itself. And because the pull target is that bone, we had to make a little bend in the actual IK rig towards that. And I'll show you that in a second, but you can see it moves really nicely right now. And if I go in and I clear transform, if I go into edit mode, you can see there's a slight bend towards the direction we wanted that pull vector to be, right? So this is a really easy way to tell our Blender what direction we want our pull vector to be, to our elbow to point at. It does change the rotation of those bones slightly. It does mess up the rotation at a very small amount. However, this is a pretty negligible difference, especially for an IK rig where the position of the wrist, of that wrist control, matters most. You can see here it's very easy to change our location of our wrist in relation to the rest of the body. And you can see the rest of these constraints. There are no constraints here, except there is a constraint at the shoulder. Not at the upper arm, because the upper arm sort of follows. It's already a child of the shoulder, so it already has technically a constraint on it. But we're not really moving the forearm or the upper arm on its own. You see, if I rotate the shoulder, everything else rotates with it. And because the hand is stuck in world space, as we mentioned before, it won't curve like FK does, like this. Right? So there's no curvature when I rotate the shoulder. The chain does not follow suit. But I can freely rotate or move the arm as such. Right? And it's very nice and smooth. And then I can move the entire chain. However, if we wanted, for example, here's a little test. If we wanted to make sure that the arms don't float in world space and are actually binded to our local space, we'd have to parent those or strain those boxes to the root of our rig. So if I go into edit mode, select those parts of our control rig and then parent them. Now you can see if I move the base of the arm, the control follows. And then I can still move and adjust the IK while it's in this hierarchy, right? And I can also add the pull vector to the hierarchy of root bone. So only this root or whatever bone you want to make it attached to will affect its transform. And so this is a good way to differentiate where our world and local spaces are of our model and our imposed spaces and whatnot. And that's helpful if you want to bind or attach a hand to a ladder, for example, as we've talked about, or if you want the IKFK to be attached to the rig itself. And you can automate this process. You can add a little custom property into a bone to switch between the local and world space of those IK bones. And that little bend that we gave to the pull vector, you can see it points directly towards that pull vector, or that bend points directly to the pull vector, and that prevents any Blender strange guesswork of where our elbow is pointing. So that's just the pull vector will always be where the elbow is facing. You can see it. If I move it, the elbow points at it. So now moving on, we have the FK IK switch. And so we want to be able to have both the FK and the IK on the same rig. But if we want to animate and switch between them, how do we do that? We don't always, as I mentioned, we don't always want to animate FK. We can create a custom property on a dedicated controller bone to do so. So drivers are used to blend between visibility modes and constraint influence amount. This is the IKFK switch, and you can see in here, it has both the IK and the FK. And so if right now I have it in between, you can see it's set to 0.5. And so right now you're not really able to animate it. So if I set it to just 1 fully, now it has full influence on the IK. So I can just take this and set my IK limb wherever I want it to be. And then we'll take the shoulder, move that. And then if I now switch over, you can see it blends really nicely. And so this is our FK. Right, and so, I mean, it's not the most elegant solution, but it's one that works pretty well. Ideally, you wouldn't want the bone to drift off to the other switch here. You see, it just kind of drifts over. That's because I moved the origin point or the root bone. But yeah, you can see nice little blend between them. And the reason why, when it's in between, you can see both is because the on and off, I'll show you it right now. If I go into, let's say this bone here, I put a driver on the hide option under bone. And so right now, it will only take in a full, like a full integer. So once it hits 1, it will turn off instantly. And then once it hits here, it turns off instantly. But the influence, you can see if I turn on the mechanism bones, you can see that there are 2 mechanism bones now. And this is exactly why I was saying we should make mechanism bones as well for the FK, because it's more consistent when you have the IK and the FK both with those specific mechanism bones that are the exact same. There's the exact same amount of layers for both of these systems. It's much easier to read, much easier to understand. You're not like, okay, why is it straight to the control bone for the FK? Right? This just breaks things up nicely. And you can see the actual blending between isn't on these mechanism bones. It is on the deformation bones. And that's why I would recommend making the intermediate bones, because when you're blending between different constraints directly at the deformation level, it's a bit scary, you know? You don't want to be doing so much at the deformation level. So you can see here is the influence. Right now it's set to 0.528. I wonder if I can pin this. No. And then if I go to the edit driver, it's a very linear relationship. As, here we go. Oh, let me just lock this here. Hello. No, it's not staying on here, but as I change this property, you can see that the deformation bone goes to 1 here and then the opposite. And since it's a float value, it will blend nicely. And yeah, that is some nice IK-FK switching. Let me just clear transform. Oh wait. Here we go. Clear all. And that leads us into just the live example of the ladder I showed you earlier. So you see here, I can climb the ladder a bit. I can do like a little animation sequence. Let me just try that out. So if I go I, little thing. You see? Super easy, very straightforward. However, if I wanted to try, let's try this. It's your keyframe. So you can keyframe the switch, right? Now it blends between. It's a bit jarring the way I did it here, but it's just for example. And then now, if I try to animate it, like, what am I going to do? I'm going to move this first a little bit, and then fix the chain around it. And then what? I have to animate every single bone that I moved. Like, it's very confusing, you know. I move this up a bit, rotate, rotate. See, it's doable, but it's sloppy. The hand just floats around. So you can see if I do play them all back. Right, that doesn't make sense. And so that's why we have the option for both. Next is I want to quickly just touch on bendy bones. This is very useful for stretchy rigs, as you've been learning. And as we're currently learning, B-bones are a powerful way to create stretchy rigs within Blender. They are exclusive to Blender, however, so exporting out of engine requires careful use of bone transformations and hierarchies on the deformation level. In this example I'll show you, I flatten the arm bone hierarchy to parent under the shoulder. So I'll show you in a second here. It's not the best implementation. You can see there's a bit of weight pain issues and everything, but this was just a way to showcase the bones working on a deformation, like actually deforming a mesh. So I have it 6 segments. You can see here there is the start and end handle. Those are set to the MCH bones. I'll show you that in a second. But what I want to really show and put in the spotlight is I have all the upper and forearm at the same level as just as the children of the shoulder itself. So this is the parent. These are all children directly underneath it. And so there's good and bad to this. It's good because if you are making your rig fully in Blender and animating it all in Blender, this has zero problems with any sort of weird transforms problems. However, if you are maybe doing a custom IK or something in a different engine, you won't understand what's going on. It's like, why is the hierarchy broken? Why is the chain broken? So it's very dependent on your use case. I believe there are different ways to do this. You can still have them in a chain. It's just you got to do some more complicated workaround solutions. This was just the easiest one. And then now, because of this, all those bones can move freely instead of the main problem that we're trying to avoid is scaling the bones, because when we scale the bone in engine, it scales every single bone down the hierarchy. And so if you can imagine that if you scale up your forearm, if it's stretching, all those fingers in the hand will stretch out as well in a very unrealistic way. I don't have an example, but that's why we do this, because engines don't know the difference. But in Blender, you can scale bones separately, right? So I'm just going to showcase this bendy bone I created. I tried to make it as not as complicated as possible. So starting things off, we have the start and finish. Let me just pull all these up. Bendy bone start, bendy bone end, and then middle offset. So you can see I just start dragging this. Pretty straightforward. I have about 6 segments each here. And then if I go into, I change it to X-ray mode, there we go. This is the, so this is the main chain, bendy bone chain. I call the MCH bendy bone main. And so this one tracks simply the distance between this bone, or the offset between this bone and that bone, and then creates a curve in between, right? And if I go to, let's see, constraint, stretch 2. So this bone is parented to the BB start. So it's just a parent-child relationship. That's why it's able to move with it. However, the end of the bone up here, it's stretching to this BB end right here, right? So I change that. Oh, sorry, not that one. This one. So you can see it's influenced by that, right? Turn that off. It's just completely off. Rotate. See. I can move this all back. There we go. And yeah. And then there is a second layer I added. You can see here there's 2 more bendy bones, and they are blending to this midpoint, and then this midpoint blends to the final BB end. And it's pretty similar. It's a stretch 2, so stretching from here to here, and then stretching from here to the end, right? And this bone in the middle, this one keeps that control, or this control we can interact with following the center of this chain here. So you can see, copy transform by default will just go in a straight line like this along from the head to the tail of the bone. This is where having a head and tail is important. But then there is an option here, follow B-bone. So this is B-bone specific. It will follow that curvature. And so we can set this pose bone. And then now, any offsets we make will be in relation to that bone in the middle, right? It's not perfect. You can see the squash and stretch that naturally B-bones do sort of shoots it off to the side, which is not ideal. Ideally, we'd want maybe this bone to get closer as we bring it back in. But this is just the example I wanted to show, right? It's one thing to see it here. It's another thing to see an example, right? So here's my very not broken bendy bone setup arm. And you can see it's the same bendy bones from over here. However, now they are deforming this mesh, and they have controls to manipulate them with. So I can now stretch out this arm using these controls. And look, you can see how poorly some of these deforms are, but you know, it was an attempt. You see the natural squash and stretch of the bendy bone is being translated into the deformation, the actual deformations. And getting these intermediate bones here to work was a bit of a challenge, but I figured it out. It was a constraint. So I had to copy. This bone is copying the transform of the bendy bone, in the middle bendy bone. Sort of the way that this bone copies the constraint or copies the transform of this bone here. Right, so this one here is in the middle. This bone here copies that bendy bone, and then this one here, which is what we were originally moving around, is now constrained to this bone. So it's sort of adding an extra constraint, whereas we were originally directly manipulating this part. Now this part is watching for this constraint here, and this constraint, or watching this control bone here, and this control bone is watching this here. And so I set it to local with parent so that, and before original, so that you can make changes to the bendy bone. And since it's before original, I can still move it sort of like an offset and then move everything else with it. You see that problem arises where as we bring it close, it sort of stretches out way too far. And that's not nice. Currently don't have a fix for that, but I'll have to research on that. And I mean, this is fun, but you see it has its problems. I think the hierarchy is still, this bone's still in the hierarchy. So it's copying the rotation. So I'd have to fix the hierarchy problem for that. But this is not the best implementation. I tried to make a IK with bendy bones, and so I tried to make it so there is the problem where when you have an IK and then the arm kind of maxes out, it's stuck, and that is not. It's not always the best when you're making a stylized rig. You might want the arm to keep going a little bit to have some fluid motion. It doesn't just stop and snap at maximum exertion. So I only added a forearm in this case, a forearm B-bone in this case. It could be a viable animating rig if it had more polish. So go here. You can see, oh, I didn't test that. Oh dear. Yeah, so that's a problem. I think I need to make sure that this forearm is copying this. Let me see. Oh, it's just not moving. Oh, and I also need to move the position. That's why. So I'm also at copy location and rotation. Okay. Let's see how this works. Set it to local with parent on both. And so now, there we go. Now it moves with it. See? Constraints are amazing. And now you can see it's stretching. It's fun. You can see the stretching away from the arm itself. So that's a bit more fun than the hands just sort of, when you pull away from your controls and then your arms just go like this. Now it's kind of milking the idea that your arms are stuck in the world space. So now your arms are just stretching away from that point. You see? You can hide the B-bones and you can see it better. So I can also move the end of the chain here. There is a bit of a problem I've noticed where the curve of this B-bone affects the weight painting near the edge over here. I think that's the way I set up my deformation bones themselves. Because they're so long here, you can see that this influence goes past the wrist and sort of shoots it off a little bit like that. You can see this is a way to get that little stretchiness as you push it off into infinity. Ideally, you wouldn't want to go off forever, but in this case, that's what it is. It just makes it more annoying because you do have to weight paint a bit more, and the weight painting for this is very annoying. You need also more geometry. Maybe I try to smoothen this out a bit. Just a little smoother, but yeah, just some fun with controls. And I also have this intermediate stretch, but there's not enough bones and there's not enough work done, so it's very choppy. Ideally, you'd want a lot more deformation bones for this. But then again, you're not going to be stretching this wildly for most characters, you know? It's very subtle in most cases. So remember that as well. Most of the time, these effects are going to be subtle. So you don't need an insane amount of, can this stretch really far or whatever, you know? Just, yeah, it works pretty well. I'll have to re-record that audio I missed it earlier, but I think for now that's kind of what I wanted to cover. Nothing crazy, just a little bit of control rig stuff. And this is just a little GIF I made. And so that's it for this week. Thank you all so very much. I won't keep you any longer than is needed. And yeah,